Hello, friends. Welcome to Science Talk. I'm your host, Jim Massa. I want to discuss with you in this video segment Jetstreams. Now, I've done a video segment before where I talked about how global warming is changing the jet stream flows as well as the intensity of it. Well, this particular study that I'm going to share with you, which was published in the journal Nature Climate Change, examines how changes in the jet stream will negatively impact the global breadbaskets. In other words, major areas of crop growing. So, in other words, what is possibly can happen is that food shortages and disturbances to to the civility of matters, well, that's already underway, could happen. So, we have a bunch of folks whose names I want to share with you, before we dive into the study here. As published in the journal Nature Climate Change, we have Kai Kornhuber, who's a doctoral candidate from Potsdam Institute for Climate Impact Research in Germany, and also associated with Lamont Doherty Earth Institute, Wally Broker's old place. We have Dr. Dim Kumu from the Institute of Environmental Studies at VU Amsterdam, and PIK. PIK is Potsdam Institute for Climate Impact Research. We also have Dr. Jonathan Donges, who is another researcher, another co-author at PIK. We have Elizabeth Vogel from Melbourne University. And finally, we have Ted Shepard, who's a professor of climate science at the University of Reading in the UK. And so those are the scientists involved here. And so what are they looking at? They're looking at how patterns of winds in of the jet stream can bring simultaneous heat waves to breadbasket regions, and these breadbasket regions provide up to 25% of global crops. Extreme weather on this scale can significantly harm food production, which will increase prices, because that's what capitalists just love to do, and this, of course, will fuel social unrest. Western North America, Western Europe, Western Russia, Ukraine, and the Caspian Sea region are especially susceptible. So these researchers looked at how specific wave patterns in the jet stream strongly increase the chance of heat waves occurring at the same time in different parts of the globe. So in other words, it's not just, this region is affected, but you have a synchronicity of major regions impacted badly at the same time. That's not just a 1-2 punch, it's a 1-2-3-4 punch. Now, as you know, jet stream is a basically fast-moving band of air in the atmosphere. It continuously circles the northern hemisphere, and it travels from west to east. It typically is a narrow band, but it can meander north and south. Now, the video segment I did earlier was explain how, with the increase of temperature, with the Arctic warming, the temperature and thus the pressure gradient from mid-latitudes to high latitudes is not as strong, not as well defined. So now the jet stream starts meandering. Instead of staying in a more zonal flow, it becomes more meridional in their flow. And we're seeing, when you couple that with like the Arctic Oscillation and North Atlantic Oscillation, affecting the jet stream and what's going on, as well as temperature increases, it's kind of meandering all over the place. But as it meanders, its flow also slows because the gradient is not as strong. So it's this narrow band. It flows west to east primarily. It can meander north or south due to what us fluid dynamicists call Rossby waves. Now, I am not going to explain all the mathematics between Rossby waves and Kelvin waves and all that stuff. Take a fluid dynamics course. and make sure you've had through differential equations. But what are Rossby waves? In a nutshell, they're planetary waves, kind of also driven by inertia. Once you get them going, they're just going to keep going. And Rossby waves are things that are typical in rotating fluids. The atmosphere is a fluid, and the Earth certainly rotates. So we get Rossby waves in the atmosphere, you get Rossby waves in the ocean. Movement is extremely complex. I am not going to get into the specifics of this. It's extremely complicated, and well, in order to explain, you have to use the math, and I'm not going to do that. Now, as I've discussed with you in my other video segments, when the jet stream starts meandering in more of a meridional manner, it will of course pull down some of the Arctic air masses down into more temperate zones. Okay, that can happen. Of course, those wobbles will affect daily weather. When they grow quite large, they can bring prolonged heat waves, droughts, or floods in summer. Or in colder seasons, very cold, very abnormal cold periods. So they've already documented that the waves have hit in 1983, 2003, 2006, 2012, 2018. The last three seem to be about every 6 years, when many temperature records fell across the US, Canada, Scandinavia, and Siberia. In other words, things warming up. As well as killing crops, the waves have killed thousands of people. Remember the heat waves in Europe about a decade ago or so. So Europeans, Russians, they've been subjected to these really bad heat waves with a lot of fatalities, mostly among the elderly, but it's still. And in Europe and Russia, they tend not to have air conditioning units in their homes. They just don't. The research shows there's been a significant increase in the probability of multiple global breadbasket failures, particularly for wheat, maize, and soybeans. For soybeans, the implication of crop failure in all major breadbaskets associated with climate risk would be at least 12.55 million tons of crop losses, which is far more than the 7.2 million tons lost in 1988 to 89, which was one of the largest soybean production disasters, really. So Kai Kornhuber, who I've mentioned before, he found in these simultaneous heat waves can significantly reduce crop production and create the risk of multiple harvest failures and other consequences. He states, we found an underexplored vulnerability in the food system when these global scale wind patterns are in place. We see a 20-fold increase in the risk of simultaneous heat waves in major crop producing regions. During these events, there actually is a global structure in the otherwise quite chaotic circulation. The atmospheric pattern the team research mean that heat and drought become locked into one place simultaneously, where they then affect the crop's production yields. I've done previous videos where I discuss not just heat, but drought working or hitting a region at the same time and the devastating consequences. This is another study looking at that scenario. What makes this particularly relevant, Kornhuber goes on, the bell can ring in multiple regions at once, and the impacts of those specific interconnections were not quantified previously. Now, let me stop for a moment and explain what's meant by interconnection. Interconnection is basically how major atmospheric systems communicate with each other. In other words, if I've got something going on in the mid-Atlantic oscillation system, or the North Atlantic Oscillation System, that will affect the Pacific Decadal Oscillation System. Pacific Decadal Oscillation will impact what ENSO does, and so on. So we have all these systems, not necessarily, ENSO is here, PDO is here, NAO is here. They're all connecting, all doing things together. So you could have a set of conditions over here that will then give rise to a similar set of conditions over here. That's what he's referring to, the interconnections. Basically, conditions are set up that similar conditions worldwide occur. Now, Dr. Kumu basically states, normally low harvests in one region are expected to be balanced out by good harvests elsewhere. But these waves can cause reduced harvests in several important breadbaskets simultaneously, creating risk for global food production. And then Dr. Donges states, we will see more and more heat waves striking different areas at the same time, and they will become even more severe. This can impact food availability not only in the regions directly affected, even remoter regions, that's his word, we can say more remote regions, may see scarcities and price spikes as a result. And of course, those living in poverty can't afford their food risk. They can go hungry, starve. Dr. Vogel states, during years in which 2 or more summer weeks featured the amplified wave pattern, cereal crop production was reduced by more than 10% in individual regions and by 4% when averaged across all crop regions affected by the pattern. Dr. Shepard, we have strong observational evidence of this wave pattern. What is open for discussion is how it might respond to climate change. In other words, more research is needed. Professor Shepard goes on to say, many consensus scientific statements, including those from the Intergovernmental Panel on Climate Change, IPCC, have proved to be, wait for it, underestimates of how fast and how far the effects of global warming might move. There's a shock, the IPCC underestimating things. Who would have thunk? No sarcasm. So it's one thing to talk about, climate change is going to affect the jet streams this way, and you could, you get colder winters in Louisville, Kentucky, what have you. But now it's looking at saying changing jet streams could impact crops, impact our food supply. This is serious, folks. Thank you for your time. Hello folks, this is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.